For question number 30, we look at definition 1. Definition 1 states that GPEP, the gravitational potential energy of a sphere at point P, is equal to mgHp, where m is the mass of the sphere, g is the acceleration of the sphere due to Earth's gravity, and h is the height of point P above point L. If you look at student 1's statement, student 1 states that the sphere slid down the incline and the gravitational potential energy was converted to kinetic energy. And since sphere y had a greater mass than sphere x and g and hp were constant, sphere y would have a greater gravitational potential energy. And hence, since this GPEP was converted to kinetic energy, sphere y would also have a greater kinetic energy of the sphere at point L. And because of this, sphere y would slit further up to the left-hand side of the incline compared to sphere x. Based on this information, we apply definition 1 to the question. We know that the mass is constant since we are only looking at sphere x. The hp, which is the height of point P above point L, is also constant. The only thing changed out here is the g, which is the acceleration of the sphere due to Earth's gravity. The acceleration of the sphere due to Earth's gravity would be greater when you compare it with the acceleration of sphere due to Moon's gravity. Hence, the gravitational potential energy of a sphere at point P on the Moon would be lesser. And since student 1 stated that the GPEP was converted to kinetic energy, and if GP, the gravitational potential energy, also is less, the kinetic energy would also become relatively lesser on the Moon. And if the kinetic energy decreases, sphere X on the Moon would not slide much further on the left-hand side of the incline. The kinetic energy of sphere X for the study of the Moon would be less. Hence, A and B are eliminated. C states that it will be less because the acceleration due to gravity on the Moon is greater than the acceleration due to gravity on Earth, which is not true, since the acceleration due to gravity on the Moon is less. Hence, option D would be the correct choice.